Hello everyone and welcome back. So in this particular lecture we learn some very important topic on vector calculus. So what is vector operators? So there are three vector operators. One is gradient of a scalar field, then divergence, and then curl. So before going to learn what is gradient of a scalar field, we need to know some definitions like what is scalar point function, what is vector point function, and what is level surface. So specially in this particular lecture, we learn what is gradient of a scalar field and its physical significance. So in the upcoming lectures, we will learn what is divergence and curl. Okay, so let's begin. Now, what is vector or scalar point function? Now, what is scalar point function? You see, if a scalar quantity phi, so we have taken a scalar quantity, right, phi. Suppose phi is a function of a particular point. Okay, particular point. Suppose x comma y comma z is a point in space. Okay, x comma y comma. So if phi is expressible in terms of x, y, and z, that means what? Phi is dependent on x, y, and z. So then this particular function phi of x comma y comma z is called what? Scalar point function. Okay, so it's very simple. Let us take a scalar quantity phi. If phi is dependent on x, y, z, what is x, y, z? Any point in space. Suppose if we draw x axis, y axis, and z axis, x axis, y axis, and z axis, and this point is suppose x comma y comma z, and if phi is dependent on, suppose if x, y, z change, then phi will also change, but there is no direction here. Direction is not involved here. Only phi will change with the values of x, y, and z, and x, y, z are what? Scalar numbers, or what? Cartesian coordinate. So phi is a scalar function. If phi changes with the change of x, y, and z, then this function phi of x comma y comma z is called what? Scalar point function. Like density, temperature, these are all what? Scalar point function, because we know that in density or in temperature, body temperature, or body temperature, direction is not involved. Okay, so you only need the magnitude. So when we talk about a scalar point function, then some relations are there. This relation will be very useful. So suppose you go through this, so you already know these particular relations from the differential calculus. Now let us come to the vector point function. What is vector point function? So when we say vector point function, the same thing. Now here see, phi is a scalar function. Now v bar is what? V bar is a vector quantity. Okay, so if v bar is a vector quantity and this v bar depends on some point x comma y comma z in space, then v bar together with x comma y comma z is called what? Vector point function. Okay, so it's very simple. Function, the main thing is the function. If the function is a scalar function, then it is a scalar point function, and if it is vector, v bar is vector, then v bar of x comma y comma z is called what? Vector point function. Similarly, we have two results again. They are similar kind of result. So this is for scalar function and this is for what? Vector function. That's why we need the direction here. Now the important thing comes, level surface. What is level surface? Suppose suppose there is one space. This is one space. Okay, this is one space, and there are some point. There are some point where the value of phi is same. Phi of x comma y comma z is a scalar point function. This is a scalar point function which is continuous also in this particular region. Now the surface drawn in space containing all those points where phi of x comma y comma z has same value, means see, I have given some dotted marks, right? So suppose at this particular point phi of x comma y comma z is k. Similarly, we find another point. At this point also phi of x comma y comma z equals to what? K. So we take some point where phi of x comma y comma z is what? Constant. So now if we join these points, then we will get a surface, and this particular surface is called what? Level surface. Level surface means at this particular surface, at each and every point the value of phi of x comma y comma z is what? Same. Like equipotential surface, where at each and every point potential energy will be same, like isothermal surfaces. So these are the surfaces where the value of the function what remains same. Okay, so these are some important words that we need to know. Now come to the definition of gradient of a scalar field or scalar function. So what is gradient of a scalar point function? So first we need vector differential operator. Okay, so you can write all the notes from this definition. So make a proper note so that during exam it will be helpful for all of you. Now first we have to take a differential operator. Okay, differential operator. This differential operator is denoted like this. Either we'll call it nabla or what? Del. Okay, del. So this particular symbol, it means I cap del del x, then j del del y, and then what? K del del z. So this is nabla. Nabla is vector differential operator. Okay, then you need one scalar point function. That's why I have explained scalar point function first. So we need a scalar point function. So just now we know that then phi is a scalar quantity or scalar function which is dependent on Cartesian coordinate system x comma y comma z. Then this is together a what? Scalar point function. Now if we operate this phi with delta, then it will become delta phi. So now it means the I del del x, j del del y, and then what? K del z of what? Phi, right? So it will become I del phi by del x, j del phi by del y, and then what? K del phi by del z. Now this delta phi or nabla phi, del phi or nabla phi is called gradient. Okay, gradient of a scalar point function. So this is, we can denote like this also, grade phi. So either we'll write it nabla phi or grade phi. So this grade phi or nabla phi is nothing but what? Gradient of a scalar point field or gradient of a scalar point function. Now interestingly, you see phi is a scalar function, but when you find grade phi, no, I, j, k is there. So this is a vector quantity. Okay, so this is a vector quantity. So maybe one mark short question will come. So gradient of a scalar point function is vector or what? Scalar. So obviously it is a vector quantity. Now from this we can generate one very interesting result also. Suppose there are 2 points in space. At this point, suppose it is x comma y comma z, and the position vector is suppose r bar. If we take another point, suppose q, whose coordinate is x plus delta x, y plus delta y, and then what is z plus delta z. Delta z, this is suppose what? R bar plus delta r bar, and this is what? PQ bar. So if you want to go along this direction, PQ direction, then what will get? Now see, d phi. D phi can also be written like this, del phi by del x dx. We wrote one relation like this in the scalar point function, plus del phi by del y dy, and del phi by del z what? Dz. So okay, so when you can write this, if phi is a function of x, y, z, then we can write like this relation. Can we write this del phi by del x, j del phi by del y, and then k del phi by del z dot xi plus yj plus zk. Now see, this xi cap, yj cap and zk cap is nothing but the position vector of P, and this I del del x, j del del y, k del del z is nothing but gradient of the scalar point function. Now if we take the dot product of these two, again this result will come. So this is nothing but nabla phi, and this is what? R bar. Okay, so this result is again very important in some examples. d phi can also be written like this, nabla phi dot what, r bar. Now, since nabla phi is a what, is a vector quantity, so a vector quantity has both magnitude and direction. So what kind of direction it has, what is the magnitude or what is the maximum value of the magnitude, that is very important to know. So this comes under physical or geometrical significance of a gradient of a phi. Now this question is very much important for exam. So in most of the question you see what is the physical significance of gradient. So that will come. Okay. So we have to understand this very, very carefully. Okay. Now let's see what is given here. Let P within bracket x comma y comma z be any point, right? So this is the point, P point, whose coordinate is what? X comma y comma z. And the position vector is what? Position vector is r bar. R bar is the position vector of this point P. Then dr bar will be what? Dr bar will be, since coordinate of P is x comma y comma z, so dr bar will be dx, I dx, ix plus jy and then zk cap, xi cap, yj cap and zk cap. This is r bar. Now let us take another point Q on another surface. Q is another point. This is a very neighboring point or nearer point. So Q is another point, but it is on the different surface. So position vector of Q will be what? Position vector of Q will be r bar plus delta r bar, right? R bar plus delta r bar. So PQ bar is how much? PQ bar is delta r bar. Now this relation just okay, this relation just now what I have shown to all of you. So this is nothing but there is one simple mistake, I guess. Yeah, it's dx, dy and dz. No, so it will be d and d. So it will be dr bar. Okay, dr bar. So d phi equals to nabla phi dot dr bar. Now coming back to this relation, you see just now we have shown that d phi is how much? D phi is equals to nabla phi dot dr bar. So here nabla phi is nothing but what? Gradient of the scalar function phi. So since nabla phi is a vector quantity, so we want to know the direction as well as is what? Magnitude. So for that what we did here, we have taken Q, another point, right? So what is the position vector of what is the coordinate of P is x comma y comma z. So coordinate of Q will be x plus delta x, y plus delta y and z plus delta z. Slight change. What are the changes? Along x-axis delta x, along y-axis delta y and along z-axis delta z. So be a neighboring point, okay, whose position vector is how much? You already know this, r bar plus delta r bar. Now consider the level surface. So you already know what is level surface. Level surface means it's a surface or a curve where at each and every point the value of the scalar function will remain same. So just you see this scalar, this level surface. At this level surface, the value of what? The value of phi remains same. So here the function is phi, and at this particular level surface, the value of phi plus delta phi remains same at each and every point. Okay, just you remember, this is one level surface, suppose level surface 1, and this is level surface what? 2. So at the level surface 1, the value of phi at each and every point will remain same, and at level surface 2, at each and every point, the value of phi plus delta phi will remain what? Same. Now we know that what is phi plus delta phi. Since phi is a function of x, y, z, so phi plus delta phi will be a function of x plus delta x, y plus delta y and what? Z plus delta z. Now if we expand this, the right hand side by Taylor series, then this will be what? Phi of x, y, z plus delta x into del phi by del x, delta y into del phi by del y, delta z into del phi by del z, then second order term, third order term, all terms will come. Okay, now left on the left hand side we have one phi, this phi and this phi can cancel out. Okay, so what we have on the left hand side, we are left out with d phi, this d phi, and on the right hand side we have del phi by del x, delta x, del phi by del y, delta y, and del phi by del z, delta z. So what we do, other terms we have already neglected because there will be second order, third order term. Those higher order terms we have neglected. So why neglected? Because see, P and Q are very near. So in the figure, no, we make it in a magnifying way. Q is a little bit farther than P, but actually in actual sense, Q is very near to P. So that's why all the higher orders we can neglect. Now this expression, no, this expression we can write like this: I del phi by del x, j del phi by del y, k del phi by del z, and dot I delta x, j delta y, and k delta z. Like this equation, this one, right? This particular equation. Okay, we can write this one. So this is nothing but nabla phi dot what? Delta r bar. So here delta r bar means this one. Okay, delta r bar means this PQ bar. So PQ bar represents delta r bar. So what I said, Q is very near to P. So as Q approaches to the point P, so if we suppose if the point Q gradually coming towards the point P, then what will happen? Then the value of delta R, will what? Tends to 0, right? Value of delta R tends to 0. Similarly, value of delta phi, that will be also what? Coming towards 0. So as the point Q approaches the point P, this delta phi will gradually reduce, right? The value of delta phi tends to 0. Okay. Then what will happen? PQ becomes tangent to the level surface at P. So this thing we have to understood. See, if Q is coming towards P, like which direction? Like this, or you can make it like this point. So if Q is going this direction, no, you see the distance between P and Q is gradually decreasing. Now initially the distance is this one, then the distance will be gradually decrease. So if the distance is decreasing, then what will happen? Then let me show it here. Suppose this is the point P, and initially Q is a point here. Now if this will come towards the Q, the point is coming towards like this, no? So at one time what will happen? Q will come very close to Q. Then if you join this point, no, PQ, this point PQ, then it will look like a tangent to the level surface at P. Which surface? Level surface 1. So it looks like a straight line, small straight line. So that means we consider that one as tangent at the point P. So which indicates the direction of what? That tangent indicates the direction of the gradient of phi. At which point? P. And which is normal to the what? Level surface. So whatever tangent we will make here, suppose this will be the tangent. Suppose this is the tangent. So this particular tangent is nothing but perpendicular to this what? Level surface. Okay. So this is what we can talk about the direction of the gradient of phi, right? So if in question only this much is asked, what is the direction of gradient of phi? So what we have to write? The direction of gradient phi is nothing but what? Tangent at the level surface, which is normal. Tangent at the level surface, or you can say is the normal to the level surface. At which point? At the point P. Okay, now let us come to the next part. Now you see further, let the normal at P meets the level surface at Q. So this is again one important thing. So when this Q is approaching like this, no? So if Q moves this direction, so that means the distance between P and Q is gradually decreasing. Suppose this Q comes to the point, which point? P dash. So when it comes to the point P dash, so this will be what? Perpendicular. Okay. So let the normal, this normal, we are talking about which normal? This normal. So this particular normal meets the level surface 2, at which point? At the point P dash. So this direction, no? This direction is the direction which we talk here, is normal to the level surface at P. So along this direction, let us take a unit vector what? N cap. So that part we will discuss now. So further, let normal at P meets the level surface Q at which point? P dash point. So PP dash. So PP dash, that means we are talking about this particular direction. And this direction is how much? This direction is denoted by what? Delta n bar. Okay, delta n bar. If you look at very closely, what is PP dash? PP dash is nothing but the projection of PQ, right? Projection of PQ. So this PQ, the projection of this PQ will fall on this part, PP dash. So that's why we've written PP dash is, we are assuming that PP dash is delta n bar, and which is projection of PQ along the normal. Normal means which direction? N cap direction. Now, when you write del phi by del r, what does it mean? Del phi by del r. Del phi by del r. So it's rate of change. Okay, rate of change of what? Phi with respect to what? R. R, delta r. So r is along which direction? PQ direction. So that's why we are writing that del phi by del r is rate of change along PQ bar. But if we write del phi by del n, again it is the rate of change of phi, but now it's n is there, no? So along which direction? Along PP dash direction. So these are the two very important terms. Okay, so one is del phi by del r, which is nothing but the rate of change of phi along PQ bar. Another one is del phi by del n, which is rate of change of phi along PP dash. What is PP dash? PP dash is the direction where the direction or the normal at the level surface P. Okay, now let us draw the diagram here again. Now, can you write like this? You see, del phi by del r is equals to del phi by del n. So originally it is r. So if I write del n, then we should write like this, del n by del r. Okay, so this del n cancel out. So again it will be del phi by del r. Now you see, this is equals to del phi by del n, then delta n by delta r. So since this Q is approaching towards P, so this part, no, this part is considered as a triangle. So if we take this is a triangle, then this delta n is what? Base, and this we call PQ is, we can consider as hypotenuse. So you see, base by hypotenuse. So base by hypotenuse is how much? Cos of theta. So angle between delta n bar and delta r bar is considered as theta. So is theta. Now as Q is approaching towards P, so if Q is approaching towards P, then what will happen? Then this will be the limiting case, means delta r will tends to what? 0. So if we take limit on both sides, I am talking about this particular line, delta r. If we take limit on both sides, then after taking limit on both sides, this all this delta will become del phi. Del phi by del r is equals to what? Del phi by del n, and then cos theta, right? Cos theta. What is the maximum value of cos theta? Value of cos theta is what? Less than equals to 1. So if we use this condition here, less than equals to 1, then what you will get? You will get del phi by del r is less than equals to del phi by del n, since cos theta is what? Less than equals to 1. So what does it mean? What is del phi by del r? Del phi by del r is what? You see, we have written here, del phi by del r is rate of change of phi along which direction? Along PQ direction. And del phi by del n is rate of change of phi along which direction? Along PP dash direction. So this is greatest, del phi by. So when we travel along the direction of the normal, then the rate of change is maximum. So therefore rate of change of phi is maximum, rate of change of phi is maximum in the direction of the what? Normal. Okay, so this is a very important result. Okay, now let us move a little bit further. Now what we say? We say that delta n is projection of delta r bar, is the projection of what? Delta r bar. So from figure also it is clear, right? That time I told that if this is PQ, so PQ or delta r bar, then this delta n bar is nothing but the projection of this PQ or delta r bar. Okay, so bar you can write or you can remove it, no problem. Then this delta n bar, what you can write? Delta n bar. So delta n bar means is projection, no? How to write the projection vector? Projection of what? Is the projection of delta r, but along which direction? Along pp dash direction. Along pp direction, what is the normal? N cap. Is it clear? Delta n is the projection of delta r bar. So how will write? Suppose if this is a bar and this is suppose b bar. So projection of a bar on b bar, how will write? It will be a bar into, if in this direction the unit vector is suppose I cap, then it's like this. So in the same way, delta n, okay, delta n or delta n bar, whatever you say. So delta n bar, we can write delta r along which direction? N cap direction. Now we have one relation, equation number 1. Equation number 1, which is d phi equals to nabla phi dot, I think you still remember, dr bar, right? Dr bar. So now we have to take this particular relation, that in place of nabla phi, or in place of d phi means what? D phi means del phi by del x dx, del phi by del y dy. So that in short you can write del phi by del n, then what? dn. So d phi can also be expressed like this. This is the relation between partial and total differential equation. So now in the left hand side, in place of d phi, if we write del phi by del n dn, on the right hand side it is nabla phi dot what? Dr bar. This implies, again you see here in place of this delta n, what you can write? Delta n in the limiting position, this will become what? Dn. Limiting position means if we take limit delta tends to 0 and delta n tends to 0, then this will become dn equals to dr bar dot what? N cap. Now say this dn, no, in place of this dn, what we can write now? We can write dr bar dot n cap is equals to nabla phi dot dr bar. Okay, so dot product is commutative. So del phi by del n, this one you can write n cap dot dr bar is equals to what? Nabla phi dot dr bar. So if we omit dr, then what we'll get? Del phi by del n cap is equals to what? Nabla phi. So this is the value of gradient phi. Gradient phi is nothing but del phi by del n. Del phi by del n means rate of change of phi along which direction? Along the normal, okay, along the direction of normal. Since n cap is there, so this is a vector quantity, because grad phi is what? If we simply write del phi by del n, so gradient is what? Gradient is rate of change of phi with respect to n. But since gradient is a vector quantity, so we have to give the direction. Along normal, the unit vector is what? N cap. Okay, so this shows that grad phi at P represents the maximum rate of change. So you already show that, no, at the point P, this grad phi is what? Maximum. In the earlier part, rate of change of phi, which is along the outward. N cap is in which direction we drawn the n cap? You see, n cap is outward drawn normal. along the outward drawn normal, and this normal we drawn at where? To the level surface, at which point? At the point P. Okay, so you can also say that nabla phi is in the direction in which phi increases most rapidly. That way also you can say. Okay, and if you write in reverse way, then that will be minus nabla phi. If we write minus nabla phi, then that will decrease. So this is the geometrical or physical interpretation of what? Nabla phi. Now there are some important results from this gradient that you have to know, or you can prove this also very easily. So like nabla of u plus minus v, u and v are two scalar point function, you can write nabla phi plus minus nabla v. Similarly, some other results are there. Okay, so I hope this particular lecture will help you in your exam preparation. So if you have any query or any doubt, then kindly comment on the write your query on the comment box. So I'll try to reply, and hope you understand the whole lecture, and thank you for watching.